Hey, how you doing guys? It's Ilabella here. I do coding stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called maximum level sum of a binary tree. Given the root of a binary tree, the level of its root is 1 and the level of its children is 2 and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximum. We got these three right here and we return 2 because level 1 sum is 1. We have the root, only one root right here, like the only one node and level 2 sum is 7 plus 0, which is 7, and level 3 sum is 7 plus minus 8, which is minus 1. So we return the level with the maximum sum, which is level 2. Right here we got 7. Note, the number of nodes in the given tree is between 1 and the base 10 raised to the power of 4, and node.value is greater than or equal to the base minus 10 raised to the power of 5, and node.value is less than or equal to the base 10 raised to the power of 5. I'll show you how to solve this problem iteratively and recursively. The first solution is iterative one, right? So what we're gonna do that we're gonna do the breadth first search level by level, and we will be using a queue data structure. You know guys, there is a queue and we add the elements to the tail of that queue, and then we can pull the elements from the head of that queue. That's how that works. Yeah, so let's start. First we create the variable, which is called maximum sum is equal to integer dot minimum value. We create the maximum level, which is 1. You could notice that from the description of this problem right here. And we create queue of the type tree node. Queue is new linked new linked list of the type tree node. We need to offer the root, add the root to that queue. We create the variable, which is the current level, just level is equal to 1. And we create a while loop. While this queue is not empty, means there is at least one element into that queue, we need to calculate, find the size of that queue. We say size, get the size is equal to queue dot size, int the current sum, which is 0. We create a for loop, int I is 0 and I is less than the size of that queue and I++, and at each iteration we pull the element from the head of that queue. We pull the node queue.pull, and we say the current sum plus equal current node dot value. In the case when the node, the child to your left, cur.left, doesn't equal to null. Suppose we are here, your child to your left, the child to your left. We say q.offer that child current dot left, and if current dot right, the child to your right doesn't equal to null, there is a child, we add that child to the queue. And when we finish this, these iterations, finish looping through this, till this size of that queue, we need to create the condition in the case when the current sum is greater than the maximum sum. We update the maximum sum to the current sum, and maximum level level to the current level. And at the end of this while loop, we increment level by 1 every time we traverse down the tree. Finally, we return the maximum level. That's it. That's how to do that iteratively. Let's run this code. Accepted. There we go. Let's submit. Good. Success. And I'll show you how to do that recursively. We need to delete that. And right here, you need to create the list, the type integer. We'll be doing in this problem with values. Result is equal to new array list, the type integer, and you call, what we're gonna do is that we're gonna do the depth first search, right? Pre-ordered traversal means that we are here, then we go to your left, then we start backtracking and we go from here to here, and then from here to here, right? That's it. So we pass the root, this list, and we start, in this solution we start at the level the level like 0, like 1 means like 0, we start like it's 0 based. So right here we got, instead of 1 0, instead of 2 1, instead of 3 2. And finally we return like first we need to create int maximum level is equal to 0, for int I is equal to 0 I less than result dot size I plus plus, and case when result dot get at the position of, or just dot get maximum level is less than result dot get at the position of I, we say maximum level is equal to I, right? And in this problem we use the level as the index into this list, right? That means the sum at the current level. Finally, we return maximum level plus 1, and we need to also implement depth first search method, helper method. We got 3 node, like node, and we have this list, the type integer, which is result, and int, just like level. In the case when node is null, we return, and in the case when we see the value, the node at the current level the first time, when we are at the first time at the current level, we say if the length of this list, means the size of this list, is equal to the level, we add into this list node dot value. Otherwise, when we already been at that level, we need to create else condition, and when we start backtracking, we return, we get back to this level, right? Like from this right here to this right here, and we already been at this level, so we just need to say we need to say result dot set at the position of the level, and result dot get the position of the level, plus node dot value, and finally return. No, we don't return, we just say depth first search. We call this method recursively, and we pass node dot left. We go to your left first, and then we go to your right. That's how that depth first search pre-ordered traversal works. We say result and level plus 1, and we have depth first search node dot right, and result and level plus 1. Right, let me check real quick. So we just create this list, new array list integer, that per search we pass node, we pass the result, right, and the position of this level. Finally, we return max level plus 1. We are looping through this list. If result.get max level is less than result.get the position of I, we say max level is equal to I right here. And in the case when the node is null, we return. In the case when we are at the first time at this at the current level, we add the value of this of the current node to that list result. Otherwise, we say result, we modify this the value at that position, at the position of the current level, like level, right, set level result.get level, the previous value, and plus the current one right here, like 7 minus 8, like minus 1, right? And we go left first and then we go right. That's it. Let's run this code. Accepted. Let's submit. There we go. Success. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And leave your comments below. I want to know what you think again. That's really important. Thank you. Bye. I'll see you next time.